And welcome back, students. As we get into our next lesson on interfaces, today we're going to discuss the serializable and the clonable interfaces, mostly talking about, of course, the clonable interface. So let's just really quickly recap the serializable interface because we've actually talked about this in a previous lesson. Now, in the last lesson, we talked about the designers of Java often use the interface mechanism to take care of miscellaneous details that do not really fit the spirit of what an interface is supposed to be. An extreme example of this, of course, is our serializable interface. Serializable interface has no method headings and no defined constants. So if you actually look at it, it's just serializable, and there's nothing really inside of it. So as a traditional interface, it's kind of pointless because you don't have any constructs for it. However, Java uses it as a type tag that means the programmer gives permission to the system to implement file in a particular way. In fact, if you recall, we discussed this back in our file chapter in which the serializable interface was discussed in detail. So you're not really going to hammer too much on the serializable interface. If you need to remember what it does or how we use it, go back to the file chapter and reference your notes there. But let's today focus more on the clonable interface. So the clonable interface is another example where Java used the interface mechanism for something other than its traditional role. The clonable interface has no method headings that must be implemented and no defined constants. So again, it's kind of like the serializable interface. However, it is used to say something about how the method clone, which is inherited from the class object, should be used and how it should be redefined. So what then is the purpose of the clonable interface? When you define a class to implement the clonable interface, you're going to redefine the clone method, inherited from object, in a particular way. The primary motivation for this appears to be security issues. Cloning can potentially copy private data if not done correctly. Also, some software may depend on your redefining the clone method in a certain way. Now, programmers tend to have strong and differing views on how to handle cloning and the clonable interface. So what we're going to look at today in the notes is pretty much the official Java stance on how to do it. Now, the method object.clone does a bit-by-bit copy of the object's data in storage. If the data is all primitive type data or data of mutable classes, such as string, then this works fine and has no unintended side effects. However, if the data in the object includes instance variables whose type is a mutable class, then this would cause what we refer to as privacy leaks. So to avoid these privacy leaks, when you define the clone method in a derived class, you should invoke the clone method of the base class object, or whatever the base class is, and then reset the values of new instance variables whose type are mutable class types. So reset these instance variables to copies of the instance variables in the calling object. There are also issues of exception handling to deal with as well when we look at this. An example, of course, might be a little bit clearer than just us talk about this abstractly. All right, so let's just start first with a very simple case. Suppose your class has no instance variables of a mutable class type, or to phrase it differently, suppose your class has instance variables, all who are either of type primitive or are immutable type like string. And to make it even simpler, suppose your class has no specified base class, so the base class is object. If you want to implement the clonable interface, you should define the clone method as in your clonable class. So I'm going to pop over to the Eclipse quick, and you can see right here is your clonable class. It implements clonable. In here, I just have public object clone. You notice we're using object here. Try catch. It's going to try to return super.clone, which is just an indication of the clone in the base class object. Then you also have catch, which should not happen, but if it does, it's just going to return null in order to keep the compiler happy. Now, the try catch blocks are required because the inherited method clone can throw the exception, clone not supported exception, if the class does not correctly implement the clonable interface. Of course, in this case, the exception will never be thrown, but the compiler will still insist on having try catch blocks. Now, let's suppose your class has one instance variable of a mutable class type named data class. Then the definition of the clone method should be as in your clonable class too. So if we look over here, we can see that we're implementing clonable. I have a private data class named some variable, public object clone, again try catch, but you notice our try is a little different. We have your clonable class 2 copy equals your clonable class super.clone, copy.some variable equals data class, notice it's a typecast here, some variable.clone, return copy. So first, a bit-by-bit copy of the object is made by the invocation of super.clone. The dangerous part of copy is the reference to the immutable object in the instance variable, some variable. So the reference is replaced by a reference to a copy of the object named some variable. This is done with the line copy.someVariable equals data class someVariable.clone. The object named by copy is now saved and can be returned by the clone method. If there are more instance variables that have a immutable class type, then you repeat what we did for some variable for each of the immutable instance variable types. So this requires that the class type data class has a correctly working clone method that is marked public that will be true if the data class type data class implements the clonable interface in the way we're now describing. That is, data class should implement the clonable interface following the model of your clonable class or your clonable class 2, whichever is appropriate. And I have an example of that up in the class materials. So similarly, all classes for instance variables in data class should follow the model of your clonable class or your clonable class 2, and so forth for classes for instance variables inside of classes all the way down. You want every class in sight and every class used in every class in sight to follow the model of your clonable class or your clonable class 2. The same basic technique applies if your class is derived from some class other than object, except that in this case, there's normally no required exception handling. So to implement the clonable interface in a derived class with a base class other than the object, the details are as follows. The base class must properly implement the clonable interface, and the derived class must take care of any mutable class instance variable added in the definition of the derived class. These new mutable class instance variables are handled by the technique shown in your clonable class 2 for the instance variable some variable. As long as the base class properly implements the clonable interface, including defining the clone method as we are describing, then the derived class's clone method need not worry about any inherited instance variables. Also, usually you do not need to have try and catch blocks for clone not supported exception because the base class clone method, super.clone, normally catches all of its clone not supported exceptions, so super.clone will never throw a clone not supported exception. Whew, that's quite a mouthful if you think about it, but remember super.clone, it's your best friend. Alright, and that's going to wrap up today's notes for today. Whew. A lot of stuff with cloning here going on, but it's a little overwhelming and it may be a little bit confusing, but we're going to kind of put a wrap on our first discussion on interfaces, and I will see you next time.